Assalamualaikum, welcome back everybody. So today we are going to learn new chapter, which is the fatty ester. Okay, so we are going to cover this chapter for 2 weeks, for weeks 8 and also 9. So let us see what is we going to learn in this chapter. As usual, for all the derivatives, for all the basic oleochemical, we are going to learn three things. First is their production process. So we're going to learn the productions of fatty ester and its derivative. And also we will see the flowcharts on the production process of fatty ester. And lastly, the uses and applications. Okay, at the end of this course, so you are able to learn from this chapter is first, you are able to define what is the fatty ester, and also you are able to describe the production process of fatty ester and its derivative, including their uses and also the applications. So this is the flowcharts for your overall oleochemical products. So started from the raw materials of oils and fats, we will obtain our basic oleochemical. For this case is the fatty acid methyl ester, or we call it as the fatty ester. So for the derivative from fatty ester, we will obtain the sulfur fatty acid ester. So there are direct productions of your fatty ester from your raw materials of your triglycerides. Okay, so the compositions of the fatty ester. So fatty ester is an ester group. So fatty ester is a type of ester that results from the combinations of the fatty acids with an alcohols. So we can obtain our fatty ester by the reactions of your fatty acids here from the carboxylic acid and also the alcohol. So the product produces your fatty ester, and it can be water or the alcohol. They are by-products depending on the chemical reactions and the components. Okay, so ester are derived from the carboxylic groups. So it is from your fatty acids. So the carboxylic acid will contain the COOH group for the carboxylic groups. Okay, what is ester? So the common ester is ethyl ethanoates. So we will obtain our ethyl ethanoate from the reactions of your fatty acids, and also in this case our ethanoic acids, and also the ethanol, the alcohol. So you will obtain the ethyl ethanoate. So the formula for ethyl ethanoate is here. You can see the R bonds for the ester, C double bond OO. Okay, and also the alkyl group, which we obtain from the reactions here. So you can see we have the ethanoic acids, 2 carbon atom, and ethanol, 2 carbon atoms. So we have here 2 carbon atoms for ethanoic acids here, and also the ethanol here. So the combination will give you ethyl ethanoate. So the naming starts from ethyl from ethanol. Ethanoate is from the ethanoic acids. Okay, so this is the naming as I said earlier, and we have our byproducts, which in this case is the water. So notice that the ester is named the opposite way around from the way the formula is written here. So it is even though we take the ethanoic acid first, it will at the backwards of the reactions ethanoites. On the other hand, for your alcohol, it will stated at the early formula here. Okay, let us proceed with the flowcharts and productions of fatty ester. Okay, there are two ways in order for us to produce your fatty ester. There are trans-esterification process or esterification process. So direct productions of your fatty ester from triglyceride is trans-esterification. But if your fatty ester produced from fatty acid, we call it esterification. Remember this, there are two ways to produce your fatty ester: trans-esterification from triglyceride and esterifications from your fatty acids. Okay, there are two ways the productions here. Okay, just remember this. Okay, let us proceed with your trans ester lubrications. Okay, trans esterifications is the reactions of your triglycerides with the alcohol with the helps of the catalyst, and you will obtain your fatty ester and glycerol. In this case, your triglyceride will react with the methanol. That's why the product is methyl ester, and the byproduct is your glycerol. Okay, so one of the applications of fatty ester in the biodiesel production. So usually we use our palm oil here. We react with alcohol and with the help of the catalyst here, and we will produce our methyl ester and glycerol. So our methyl ester is our biodiesel that we use in the formulations of your biodiesel. So depends on how much you put the methyl ester in the products. So your fatty, this is the reaction in color. So you can differentiate how we produce our biodiesel or our fatty ester. So alcohol will mix with your fatty acid here to produce fatty methyl ester, and also byproducts of glycerin, or we call it another name for your glycerol. Okay, these reactions are often catalyzed by chemical catalyst or biocatalyst. For the chemical catalyst can be acids or base, for example now. So the common use of the base catalyst is now for the productions of the biodiesel. On the other hand, for your biocatalyst, we use lipase. Lipase is one of the biocatalysts. So the reaction we mix together to produce our product from the process of the trans esterification, and we need to separate our products into two. This biodiesel as your methyl ester and also the glycerin. So we also need to undergo some process such as washing, drying to get our pure biodiesel products. Okay, this is the view of process instrumentations diagram for the productions of your fatty ester. Okay, so as usual, we will add our triglyceride and ethanol into the reactor, or you will require some preheat before enter the reactor, and then the process happen here, and then we go to the separator. Okay, so some of the methanol we return back to column to be recycled, and your fatty ester will go to the decanter to separate the liquid solid mixtures if there are any solid present. So your film that is being purified will go top products, and your byproducts which might be the presence of the glycerol will be separated. So glycerol is usually in the solid form. So your film is in a liquid. So we can just use the decanter instead of other separations equipment. Okay, so that's all for the process. So we will continue next to the process for your fatty ester production. Okay, thank you.